All right, you ready for some more? Because some more is coming. Here we go. We're going to look at the derivative now. This is, as we mentioned in the previous video, is the definition of the derivative. Now, often the derivative is written in this manner. We say f prime of x. Now this is read as either f prime of x or the first derivative of x. And yes, it is first derivative because there's second and third and fourth and infinite number of derivatives, which most of those we're not going to have to worry about. But we will get up to probably second derivatives. Well, definitely second derivatives, but not today. So this is the first derivative. Now what I would like to do is take an f of x. So let's take f of x equals 2x plus 3. And let's find the derivative. Okay? Now, we actually know what the derivative is of this, right? Because we knew if we graphed that the slope would be 2. And because it's just a straight line, right, the slope of the tangent line, the line that touches that point, would also be 2. So we expect the slope of this line at any given point to be 2. It doesn't really matter which point you're at. So let's go ahead and look at it. So what we're going to do is we're going to put this in. So we're going to write down the limit as h approaches 0 of f of x plus h. So f of x is 2x plus 3. So f of x plus h, remember the x plus h has replaced the x. So it's going to replace x here. So I'm going to write down 2 times x plus h plus 3. So that right there is f of x plus h minus, now put this in parentheses or you're gonna forget to subtract the 3. So I'm going to go 2x plus 3 all over h. So now we're going to work this out. We're going to simplify it. We're going to do what we can to put these pieces together. So I'm going to distribute the 2. So I still have the limit as h approaches 0. Please don't forget that. So I'm going to have 2x plus 2h plus 3, distribute the minus, so I'm going to have minus 2x minus 3 all over h. Still have the limit as h approaches 0. So I've got here the 2x and the minus 2x cancel out, the plus 3 and the minus 3 cancel out, leaving me with 2h over h. I cancel out the h's, so I now have the limit as h approaches 0 of 2, and we know that the limit as h approaches 0 of 2 is 2, because it doesn't matter what h is, the h's are all gone, therefore 2 will still be 2. So I found that the derivative of the function is 2, just like we knew it should be, because the slope is 2. How about that? Was that pretty neat or what? That was pretty neat, wasn't it? Here, let's try another one. Let's do another linear to start off with. So let's go f of x. Let's do an easy one. Let's maybe do 3x. Okay, so we'll go ahead and put that in. So we'll go limit as h approaches 0. And so first I need f of x plus h. So remember I'm putting x plus h in for x. So it also needs to go in for this one right here. So 3x plus h. This is where your composite functions really starts to come in handy, because we're going to use them all the time when we're doing this. So 3 times x plus h minus f of x, which you can put in parentheses if you want. There's only one term, so it's really not going to matter too much, all over h. And so we still have the limit as h approaches 0. We're going to distribute the 3. So we'll have 3x plus 3h, and then the minus 3x over h. Note that the 3x and minus 3x cancel out, leaving me with the limit as h approaches 0 of 3h over h, which of course is the same thing as the limit, don't need that, as h approaches 0, h's cancel out, of 3, which is 3, just like it should be. The slope is 3. Now, I know you're saying, big whoop, Mr. Bauer. I already knew that the slope was 3 because I know y equals mx plus b. All right, okay, granted. So you can do it with linears already. How about a quadratic? Look at the next video and we'll see some quadratics. This is going to be cool.